Hey, what's going on, guys? Komagigins here. So the last video I've been introducing what I call CMK computer, which is the bundle of Arduino Nano or Uno on your choice, 16-bit LCD shield and 4x4 keys keypad. It has a 8-bit CPU emulator being flashed into the microcontroller, and this allows to execute user-defined instructions. And also I've created an assembly that is written in Python, so you can use user-friendly mnemonics to write the programs, and then you can turn them into the machine codes encoded as ASCII characters. Then you can send these ASCII characters via serial port to the CMK computer and execute them here on this sort of a thing, right? And also as the runtime environment, allowing to provide the commands to load, save programs, run programs, view the memory. There is a built-in hex editor, which serves as the runtime environment, basically, and that's inspired by the Apple I computer, so something very similar to what was there, basically. Okay, so starting from this video, I really want to make some sort of a video documentation on how actually to program this computer, because so far I've only been demonstrating the end result programs, so what we can do with this sort of a thing. And the most sophisticated one was the Chrome Dino running on this tiny little LCD shield, but eventually they're available up to 40 instructions and quite pretty lots of things to cover here, like the most common techniques that I've developed to program this computer. So there's some very interesting tricks, mostly inspired by the 6502 processor, like for instance for memory addressing modes with an offset, things like that. So really lots of interesting things to cover here. And generally, I really wanted to make, well, even though the 6502 assembly is absolutely tremendous, still I want to make something easier and more minimalist, which would rather kind of suit beginners needs, let's say. So I personally consider this assembly language to be the very first assembly language to kickstart from in order to learn to think in assembly language, right? So because when you're writing in a high-level languages, it's quite a different thing, but writing in assembly really helps you to get the floor of programming, basically, and how to control things on the lowest level. So that's one of the major reasons of why am I doing this. And another reason, I really wanted to create an absolutely independent ecosystem which can run programs inside, and the bare minimum communication with the outer world, like with my laptop, basically, with the serial port. So you can take the bytes in and store them and run the bytes. And you can also, if you've written something here using this 4x4 keys keypad, came up with some sort of a program, you can make a memory dump, literally taking all the 1K of memory from there and save it somewhere, and then you can modify and pull it back. But anyway, so that's sort of a thing. But obviously, if you're still watching this video, which I really doubt, but anyway, probably you don't have this computer at home, because I built it just a couple of days ago. And well, obviously, if you want to try it, you don't obviously need to buy all of the pieces. Well, actually, all you need to build this is the LCD shield, the 4x4 keys keypad, and Arduino Uno or Nano on your choice. But even this is not necessarily needed, because here I've provided a Tinkercad version, and let's have a look at how it works, basically. And by the way, I've made so you don't even need to create a Tinkercad account. So I've used this embedded frame that is provided by Tinkercad itself, and it runs it runs on my GitHub pages, basically. It takes quite a bit to load, but it's okay. So here we have an absolutely kind of online version. Well, I'm not sure if you can alter the code here. Probably you can. Yeah, actually. Well, maybe you can, but at very least it's not going to be safe. But you don't really need to touch this code, because this is the code of the CPU emulator and the hex editor on its own. And all you really need here is the serial monitor. So you can just make the serial monitor taking the most of the editing space. And here you can paste the program to pass to the computer, right? And well, actually, it's not in debug mode now, so it shouldn't really be printing anything here. So, but actually, if you try to save the program bytes would be stored here. However, this serial monitor in Tinkercad version has a bit of a limitation, so it's not capable of storing the entire memory kind of map, right? It just it just starts scrolling away, and the bytes that were started at first kind of gets lost, but it's not a big deal really. So if you get to that point, yeah, it's probably going to be easier to actually build this then using the real hardware. But anyway, so I just want to say that this environment is good enough to learn how to code this computer. That's what I want to say, right? And on the other hand, I just also want to say that when I was developing my Chrome Dino game being introduced here in this video, I was actually debugging on the real hardware because I consider this to be a faster and more reliable way of doing things. And it's just really an unforgettable experience to really try this on the real hardware. So if you love the project, if you love how to code it, then definitely, well, most likely you will have a desire to build this thing on your own. I mean, like when I was initially developing this, I didn't even think that I will ever bring this to the hardware state. So initially I was just developing in Tinkercad, and that's pretty much all about it. I didn't even think that I would be building this from the real hardware. But once I realized that it kind of works, I thought that like I couldn't hold myself from buying all of these parts, and they're very miserable from the price perspective. So the overall price of this, assuming the Chinese counterparts for all literally for all the parts of the computer, it's around, I don't know, maybe like $45 for all of the things. So it's just really miserable. Well, it's here in Ukraine. Depending on where you're based, it probably would be more expensive, but it's not like that fantastic amount of money. So you really can buy this. I hope so. Okay, so I think that this is kind of in regards to the presentation of what is behind the project, basically. And starting from the next video, I would like to introduce. We'll actually start. Starting from the next video, we'll start learning how to code this, how to program this computer, basically. Like, we'll have a look at how the commands work, the basic, just have a look at a couple of instructions just to print a single character, for instance, things like that. And then we'll try to run an example program as well. I'll introduce you to the assembler that I've written in Python. It's also available here in the repo. So the assembler here is available here in the CMK computer assembler.py. So here it is. So you can just easily use this assembler. Like you can simply say like Python 3 assembler.py and then the assembly file to assemble, and it would give you a nice cute output. So you can just copy paste the bytes in ASCII format, paste them here to the serial monitor, and I can even make it like this in the next videos. So paste them here, and that's pretty much all about it. You just run it on the imaginary computer, and basically you're done. So I hope to see you in the next videos within this tutorial series. And yeah, I really think that we would be walking through all of the basics here, and I really hope this is going to be exciting. Well, okay guys, this is it from my side, so thanks for watching. Until the next time, and take care.